Hello everyone, this is Maniramakrishna. So today topic వచ్చేసి మనకు పాలిఫేజ్ సర్క్యూట్స్. ఓకే, సో పాలిఫేజ్ సర్క్యూట్స్ ఎలక్ట్రికల్ సర్క్యూట్స్లో ఒక టాపిక్. సో సర్క్యూట్స్లో మనకి ఏ టాపిక్స్ అనేది ఉన్నాం కదా. సో ఇందులో ఫస్ట్ మనం ఏంటంటే ఈజీ టాపిక్. సో పాలిఫేజ్ సర్క్యూట్స్. సో పాలిఫేజ్ సర్క్యూట్స్లో ఏమేంటి? సో ఫస్ట్, సో పాలిఫేజ్ సర్క్యూట్స్లో వాట్ ఇస్ ద పాలిఫేజ్? సో పాలిఫేజ్ మీన్స్ ది phase means the winding or current. Okay, so what is the poly means is many phases winding or conductor. So we'll having the two different. So we'll having the single phase, two phase, three phase. Okay, so poly means many number of phases we'll have it. So polyphase system is the combination of two or more voltage having the same magnitude and frequency. Then it is called as the polyphase system. Okay, so types of polyphase circuits. So here's the one is the two-phase system. This is the previously used in the no. Okay, so another thing is that presently we are not using the two-phase system. So we are using single-phase system or three-phase system. So three-phase system, and here the two-phase system will having the. So is a system where it will have the two windings are connected. So one is Right. So in this one, so each winding will induce as its own EMF. Okay, so two phase EMF. So previously we are having this one. So one is if it goes the alternate connection. So here's a two phase alternator consists of two windings X and Y and displaced by the 90 degrees. Okay, so that is so EMF developed in two phase systems are 90 degrees. So in three phase we will have the 120 degrees phase shift. So here is the 90-degree phase shift. So generation of two phase system is that two coil windings extend a same number of turns in the frequency connected to the two system, and whatever is in it, okay, it's called generate the Vmax. Okay, so it's the reference we are talking. So in nowadays we are not using the any two phase system, we are only using the three phase and single phase system. Okay, so here is X and Y phases will having the degrees of 90 degrees. So winding also placed at the 90 degrees phase shift. Okay, here the vector diagram. Okay, so vector diagram is the two phase system is X and Y phases, that is 90 degrees. Here is the waveform, how it will be the waveform. Next, relation between line and phase voltage. So here is the two phase system. So A and B. So we will getting the neutral. Okay, so line volt, what is the line voltage? Okay, so line voltage and light. Okay, so we'll getting the. So here let's talk about the line. Okay, so ఇక్కడ ఏంటంటే మనకు లైన్ వోల్టేజ్ ఇస్ ఈక్వల్ టు ఫేస్ వోల్టేజ్. ఓకే, సారీ, లైన్ కరెంట్ ఇస్ ఈక్వల్ టు ఫేస్ కరెంట్ ఇన్ టూ ఫేస్ సిస్టమ్. సో వోల్టేజ్ అనేది సో మనకు ఇక్కడ డివైడ్ అయింది. సో ఈ విధంగా ఇక్కడ చూస్తాం, ఈ వోల్టేజెస్కి ఇక్కడ వోల్టేజ్కి డివిడెండ్ అవుతుంది. ఓకే, లైన్ వోల్టేజ్ అండ్ ఫేస్ వోల్టేజెస్, బట్ లైన్ కరెంట్ ఫేస్ కరెంట్స్ ఆఫ్ బోత్ ఆఫ్ కరెంట్. ఓకే, next, voltage across the winding is phase voltage. Okay, whatever the voltage is there, voltage across the phase winding is the phase voltage. Across this one, phase voltage. Okay, so in between the two, this one it's called as a, in between this voltage it's called as the line voltage. In between the A and A, okay, this is a phase voltage. Okay, voltage between the two phase terminal is line voltage, and the line point where the two windings connect is a neutral. Okay, that is a neutral that is shown. So here is the relation between line and phase voltages we can see. Okay, so this is the phase 1 and phase 2. Okay, so what is the how the line current is flowing. Okay, as like so, as you can see is the line voltage is equal root of phase. So here is the how it will be divided. Okay, as you know Pythagoras based, so based on Pythagoras. Next we will talk about the line and phase current. Okay, so here the line current is equal to phase current. Okay, and the current through the neutral wires carries the neutral wires from the root 2 of phase. Okay, the three phase system will talk the main thing. Yeah. So here the two-phase system. Uh, we'll not dealing with that system. So now we'll dive with the three-phase system. So three-phase system will having the, so that will have the three windings. So A, B, C, or R, Y, B. Okay, or else U, Y, Z, like that. Each winding is its own EMF. Okay, here is the connection we can see. So X, Y, Z are the three windings. So each are displaced with the 120 degrees phase shift, as well as current is flows through the also 120 degrees phase shift. Okay, this we can see the three phase system connections for the alternate, how its small alternator shows. Okay, so is the generation of EMF. So rotating magnetic field, how it is generated. So based on the how we are connected in the winding. So three phase systems windings is placed 120 degrees phase shift. So in mechanical, we are placing the 120 degrees, as well as the electrical, that's connection which you get, that is also 120 degrees phase shift. So whatever the EMF generated, okay, that is also in the 120 phase. So here's the generation. So in the three windings A, B, C is the same. So then induced coil, okay, the induced coil is, that is the voltage is equal to V max, okay, that is the sign. So another induced coil B is given as a V max sine B, because whatever the phase shift is, that one is the 120 degrees. Then coil B is induced as the 240. Okay, so that we need to take 0 to 120, 120 to again 120. That is the total 240. Here we can see the A to B, B to C. Okay, so here we will hitting the first that is equal to 0. So in between the how much phase shift is the 120 degree phase shift. From B to C, that is also 120. So whatever the voltage is there, that is also will get in the here. Okay, you can see. So here is the waveforms of the three phase system. So here is the waveform you can see. So this is the A. Okay, so as we observe, so A is the start with the 0 and at the peak at the 90. Then here down, and so here it's the will see here it is the 120 degrees. Okay, so B at the start at the 120 degrees, then it is goes up and here like this. Okay, again if you see here, this the waveform. Okay, so each one, okay, how it is routing, that we need to check. So some of the questions, the related the questions we having the, so there are the relation between line and phase voltage. Okay, so mostly this the things are different. The three phase questions may be asked in mostly. Next, coming to the three phase connection. So there's a two types of connection, that is the star connection and delta connection. So this is the one is for indicates the star connection, and there is the delta. Okay, so here's the three star connection indicates. Okay, in star connection also there's the two types. One is the uh, three wire system, one is the four wire system. Okay, so three phase four wire system, three phase three wire system. So neutral, okay, based on neutral and without neutral, having the two. One is three phase four wire system, three phase three wire system. Okay, so here is n indicates the neutral point. Whatever the common points combined, that is looking the neutral. Okay, so here is the, we can see the connection. How is the three phase connection diagram? So if wanted to measure the voltage or current, so how we can see. Okay, so here the line current will always see, but voltage will be different. You can see this is the A, B, C. So here we are placing in between the two. Okay, so in here we can observe. Okay, so this is the B and A. So in between the two phases, we are placing the voltmeter. That's a line. Okay, so between the uh, A and N, if you place the voltmeter, that is for phase voltage. Okay, similar to the line current and phase current, that we can see how it here measuring. So here we can observe the, okay, so here you can see the connection. So star connected load with the star connected alternates, how is the current is flowing. Okay, with last line. So three phase generate with the three phase loop. So how is the current is flowing from phase to line, okay, in between this one. So as this the one of the this thing. And another thing is the relation. Okay, so in the relation analog is mostly asked in questions. Okay, that is the one question is the uh, so line current is equal to phase current, that we need to remember. Okay, voltage will be different because voltage is divided in the three phase, okay, star connection. So that we can see here. So as we can see, the current will be same in this one. Okay, whatever the current is, the three phase current is a phase and line, that will be same, but voltage will be different because due to the star connection. So in the star connection, winding to windings, the current, okay, whatever the joints is series connection, okay, base like. So that's why it's a voltage will be divided. But in the parallel connection, the voltage will line phase voltage, okay, across the line and phases will be same. Okay, that is as like parallel connection, but current will be different. Okay. So here you can see that as we need to remember, that is the star connection, that will is called line current is equal to phase current. Okay, so here is the vector diagram. So it will get the marks in the examination. So a vector diagram represents the how we need to draw. Okay, so vector diagram, first we need to start with the any phasor diagram we need to consider. Okay, first we need to where you are needing. Okay, so which one is your, okay, that we need to remember. Okay, so here 120 phase shift. Okay, so first you need to draw the, okay, so here we need to start with like this. Okay, then 120 phase negative. Okay, this is the line. Next another 120 degrees shift. So that we need to take 3. Okay, then at the 30 degrees VAB. Okay, then about to that 120 degrees shift. Then again for this one 120 degrees. Okay, if you draw like this, you will get the easy. Then whatever you draw. Okay, so here you may draw this. Then result. Okay, so similarly, whatever the drawn this one, make it is a this one combine. Okay, then here is the joint. See, like this way you can also. Okay, okay. But we need to mention the which one is which. Okay, so we need to start with the 120 degree phase shift. Okay, first we need to draw three lines 120 based on after 130, one is the 30, then based on that 120 120 if you draw, you will get the this diagram. So this diagram represents whatever the voltages are there. So each are in the 120 phase shift and the line voltages. Okay, that is these are 30 degrees different from the phases. Okay, that we need to remember. So here is the line voltage. So we can say that, so whatever the VAB. Okay, so VAB is the vector. Okay, from the VAB, whatever the is, so we are placing the, so it's now it's not placed. So it's a mathematical representation somewhat mistake. So you may check the, okay. So whatever that is balanced load condition VAB VBC is called, okay, line, that we need to remember. But here the thing is that line voltage is equal to whatever the line voltage is equal to under root of VPS. Okay, that's two things we need to remember. So in the star connection, okay, so a star connection means, so as like series connection of two resistors. Okay, here the voltage, okay, so voltage is divided. Okay, here the star connection voltage is divided, but whatever the current is same. So similarly in the T connection, okay, it's nothing but here we can say that this is the star connection. In the star connection, the current, okay, whatever the current is same in phase as well as line. Okay, but whatever the voltage is, so here is the in the series connection voltage is divided, right? So similarly here also voltage is divided. Okay, whatever the voltage is divided. So that's why whatever the 3 is the 3 phases and root. Okay, so we'll get the root mean square. So that's when we're getting the voltage. Okay, line voltage is equal to root 3 of phase voltage. Okay, that's we need to do. Okay, line voltage root 3 phase. Next, if we talk about the power. Okay, so how is the power in the three phase circuit? So for the three phase circuits, the balance power load. So here is equal to V phase I phase equal to 1. Okay, each phase is also. Next we'll consider in three phases. That is the total power. All in three phase, 3 V phase into I phase cos. Okay, but V phase equal to VL by root 3 I phase. That we need to check the how it is taken. So either it's the phases or line. So here we'll getting the that is totally we can get resistance. Okay, so in the form of cos phi. So we are considering the power factor, right? So power factor is a cos phi we can mention. So from that we can write the whatever it is. So here three phase power. Okay, three power is equal to root 3 VL IL cos phi. I VL is the so as we know root 3. Okay, so we know that the VL is nothing but line voltage. IL is nothing but line current and cos phi. Root 3 into VL IL cos phi. That we need to okay. So these are some questions which ask. Next, we'll talk about the delta connection. So in the this is a delta connection. So delta connection is nothing but parallel circuit. So if you remember the parallel circuit, know the details. So you can answer the this uh, delta connection. In the delta connections, so as like parallel connection. So if we two resistors are parallelly connected, so how is the current is flowing? Okay. So in this one, the current is whatever the current is that is divided. Okay. Whatever the current is. So here the current is divided, right? But whatever the across the voltage is that is same. Here also, okay, line voltage is equal to phase voltage, but line current not equal to phase current. Okay, that we need to remember. Okay, that's a simple remembrance. So here is the delta connection. We can see how we are representing. So in the delta connection, so all ends are okay. So all ends are connected. It's connected to each other, and so whatever the function point, we're getting the joining points. We're getting the each phases. Okay, A, B, C. We are getting. So from that, we're writing the line and phase voltages. That we can. Okay. So as we know that we line voltages, phase voltage. Okay. So that we can mention here based on that. So here's the delta connection. So in the delta connection, uh, three windings are shown. Okay, so A, B, C and winding. So that is each one is together, whatever that is. So A, B. Okay, so V and A, B. So whatever the phase is that is V, A, B is equal to here is V, B, C and here is the V, C. So line voltage is equal to okay line whatever the line is A is equal to V, A, B. Okay, so line voltage is equal to line current. So there is no neutral in the star. So that is we didn't get the joint points here. We didn't get the any charge. So that's why here there is a neutral in the delta connection. So here you can see from that we can write the so whatever the voltage. Okay, so all are it's the same. So that's why line voltage is equal to phase voltage. Here we can see the phasor diagram. So how we can drawing phasor diagram. But current is not same in the E always, so that it's a different. Okay, so how is the similar as previously drawn? Same here also we can draw the phasor diagram. Okay, across the current. Okay, so for the star connection we draw the phasor current. Okay, so phasor diagram for the voltages delta connection we have to draw the for line. Okay, that's it. So both are it is the same. So 120 degree phase shift we need to draw, then we need to 30 degrees, then we get. So as we show here we can say the first we need whichever you are taking reference. Suppose here if you consider first here with the reference. Okay, draw it, then 120 phase shift, then another 120 phase shift first we need to draw. Okay, then whatever you are considering, so 30 we need to take. Then from this one, other 120 degrees phase shift. Okay, then other 120, like this. So you combine the both, the all, you will getting the all. Okay, dot lines. So dotted lines we are placing, so we can getting the easy. That's it. Okay. So in this way you can also draw. Okay. So that's required the uh, multiple practice to getting the accurate one. So then it will be easy. There is no need to scientific science is there. So just we need to understand the concept, then you can draw easily. Okay. So relation is the line phase line. So previous we talked about the that's whatever the so phase current. Okay, phase voltage and line voltage. Similar here is also we can use the parallelogram. So based on parallelogram, so we'll getting the VL is equal to root 3 VH. Okay, so we can see line current is equal to root 3 VH. That we can get. So here's the delta connection power we can see. So total power three phase equal to 3 3. Okay, 3 VL V phase I. So here also same. So but the line voltage line current is different. So that's why here we're getting the root 3 VL cos phi. Okay, so that is for root 3 VL also. Similarly, here also the both it will be the same. Okay, so in if you considering the delta and okay, so both will getting the same. Here we'll talk about the methods. Okay, we are measuring. Okay, so we having the some measuring instrument that we can see. So the 1 watt method. Okay, so how we can measure the uh, power in three phases. Okay, one is a 1 watt meter, 3 watt meter, 2 watt meter. So whatever it is a measurement of voltage. Okay, so how we can measure the okay power. So it's the 1 watt method. So we can we'll talk about the or each only we'll connect the 1 watt meter at one phase. Then we'll multiply into three. Okay, so here is the one. So here is the we are connected only one phase. We are connected one phase and with the neutral. Then whatever the voltage power is developed, that is multiplied into three. Then we'll getting the as a three along the whatever it is. Okay, along the in the three phase that we are measuring. So this is the connection diagram. In coming to the delta connection. So this is connection diagram for the star connection. This is connection diagram for the delta. Okay. So next 3 watt meter. So in the 3 watt meters, so we can see the this is a diagram for star connection. So in the star connection, 3 watt meters. Okay, each phases we are connecting, and all the neutrals connected to this. Okay, so whatever the load, okay, all are it will in single phase. Sorry, single watt meter we will multiply it with the. Okay, here we are connecting the three. So combine we can getting the wattage. Okay. So this is the for delta connection. So 3 watt meters how we are connected in the three in is delta connection. So here's the watt meter readings W1, W2, W. So we'll getting the next thing is the here we'll having the 2 watt meter. So 2 watt meter method what we are in. So in one phase we are not connecting anything and only two phases we are connected. So from that we can drawing the that is wattage. Okay, so how much voltage? Okay, how much power is flowing in the circuit that we are calculating. So this is for the delta connection. So for the delta connection, how it is measured. So for this one, root 3 VL I cos phi. So W1 W2 is nothing but it will get in the watt meter. So 2 watt meter with the vector diagram we can see. Okay. So similarly phase whatever the here the we will having the line. Okay, so in the previous star and delta phase diagram, so for the star connection we have draw the only for voltages across. Okay, so for delta we have draw the current. Okay, for the 2 watt meter method, so we'll having the voltage and okay, so voltage and current. So watt meter will give the power, so that power will having the voltage and current. So for that we'll drawing the phasor diagram presentation for the 2 watt meter method. Okay, so along the how it is behave. Okay, how current is flowing in this. So how we are getting. So in the this is for the 2 watt meter method. So how we can measure the power in the 2 watt meter. Okay, that we can see is the so across the each one. Okay, line voltage and current uh, phases that we are doing. So you can see the diagrams. Okay, so these are the formulas we are using. So based on the formulas, we are getting the old power in the circuit. Okay, so this is the some previous asked question. So as well as the measurement of power factor. So how we can measure the power factor. So you can get the power factor based on these equations. Okay, so I'm not getting the in-depth explanation, just the okay. So next talk about the advantage. So advantages of the our single phase system. So along the out of three phases 1 times. Okay, so result. So efficient three phase motor is more. Okay, more than the single phase motor that we can. So transmission power is cheap in coming to the three phase system, and the single phase system having the more, and the power factor in three phase induction motor. Okay, is high in the three phase system more than the single phase system. As we know, the three phase supply produces the rotating magnetic field, but in comes to the single phase system, we cannot produce the rotating field. So we require the another extra windings that we are using the for self starting is the auxiliary winding. So torque produced in three phase motor is uniform, but in the single phase we are not getting the pulsating torque. That as we know already. Okay, so rectify. Okay, three phase volt is smoother than rectified single phase volt that we have. So these are the some asked questions. So and here are the problems. Okay, so how we do? So you can check the this type of problems to calculate the getting the formulation. Okay. So in detail, I'm not explaining, just showing the how the problems may come in an examination. Okay. Yeah. Let's see problems. Okay. So these are related to the problems. Okay. You can go through the if you are in detail derivation. If you go, you can understand the how to calculate the power in the 2 watt meters method, 3 watt meters method, and 1 watt meter. Okay, that we need to uh, understand when you do the numerical calculation. Okay, then only you can understand. Okay, at least you take the three problems. Okay, for three problems for single watt meter method, one for 2 watt meter method, one for 3 watt meter. Okay, then you can understand easily how to calculate the power in each phase. Okay, hope this video might like you. Okay, anyway, have a nice day. So prepare well for your examination. Very good. Thank you.